Hello everyone, welcome to SITAC-2020 webinar series. This is Rakesh Malakar, your host. I'm a member of SITAC organizing team. We have an exciting presentation today on the data and information architecture. We are joined by a special guest, Lucas Hryniewicki. He is a colleague of mine and also SITAC mentor. Lucas is a solution and data architect at Costco Wholesale, and his specialty is data. Before joining Costco, he was with Microsoft as a data architect for many years. Before we start the presentation, a few housekeeping details. If you have any questions, please type in the chat box. And during the presentation, Lucas will pause for the questions, and I will read the questions on behalf of you. Lucas, the floor is yours.
Thank you, sir. Appreciate that. Can you just give me a shout if the sound is okay?
Okay.
Is it? Like everything is fine, like as far as the sound goes?
Yes.
All right. Well, welcome everyone. I think I agree with Rakesh. It's going to be exciting presentation, not because I'm presenting, because of the field. We're going to touch on the data field. And this is, in my opinion, I could be slightly biased, but under the enterprise architecture, it's probably the most interesting domain, especially now, these days, because it looks like the other domains are fairly mature and there is not much innovation going on in the other spaces. This one, on the other hand, is just amazing. You will see the last 10 years brought so many changes to the space that it becomes really exciting space to be in. So we're going to cover the information architecture today. And I'm very curious if you had the chance to look at the last year presentation. I did a similar presentation last year. So maybe if you could actually respond in the chat saying that yes, you actually seen the last year presentation under the same title, or no, you have not. So yes or no, that would actually help me to navigate through the overlap, because I have a large overlap related to your deliveries, and I can go through those questions through those sections faster or slower. So I see most of the no's, but keep going. So now I'll keep talking and you try to respond, and we'll just see the responders. So anyway, when I was looking at the information architecture last year, I did a little bit more on the power of data, especially from the historical point of view. I went way back to the historical events in the past and describe how the data got used in the past, as well as at current times. So I thought maybe this time I'll just extend that presentation to the other side, of the spectrum, the future of data. So when I was thinking about that, I just realized that the future of data may be actually difficult to predict. And this prediction is very difficult, especially about the future. The Yogi Berra statement about that kept me thinking that maybe I'm thinking too far, and I won't be able to accomplish that, because when I was thinking about the predictions maybe 20 years back, most of them are not true. So I kind of thinking, well, what would the plan be? And I run into this statement, and this is pretty nice. The future has arrived. It's just not evenly distributed yet. And this quote actually is pretty popular in our field, in computer science field, because it's such a true statement. And just to support that, if you look at this diagram in there, you'll see that in most cases, when we're talking about the future, which is already here, it's just not distributed evenly. We're talking about the early adopters. We're talking about this group of people who are playing with the technology, which just got introduced. It's not a mainstream technology yet. So you see the technology early adopters on the left-hand side, and the opposite spectrum of it, it's technophobes, people who are still using rotary phones at home until they break down and they won't be able to replace them. They will switch to the newer technology. Other than that, they will stick to whatever they know. So we're going to touch on the certain aspects of the future, not necessarily predicting the future, but looking at some kind of trends. And those trends should help us to more or less see the direction of the future, not necessarily to predict the future. So that's the main idea behind this presentation today. Now, we have about 90 minutes for the presentation, and then we have a QA session. I think the whole thing is scheduled for a couple of hours or so. And we have three parts which I covered last year, which are around the data. So you see the data in all of them. And the idea is that since I see that I don't see anyone who actually seen the presentation from last year, I still encourage you to go through it, because I cover these areas a little bit deeper than I'm going to cover them today. Nevertheless, I'm going to probably spend a bit more time on the data modeling side, because this relates to one of your deliveries, but I still want to have enough time to cover the other two, which are relatively new to this presentation. So I would like to cover a little bit more, maybe even switch the focus when we start running out of time to the cryptocurrency, because this is one of possible implementations for in-app currency, which is part of one of your requirements. Said that, I'll stop after each of those sections for questions. So if you have questions, just post them in the chat, and we'll, if it's something urgent, just put urgent and Rakesh will stop me. Other than that, I'll stop after each of those sections and answer any questions you may have. So you can write them as along with the presentation, and we'll try to address them. So when you look at the data landscape, and this is not like a comprehensive list of anything what's happening in here, just a few probably more known components of the data landscape. When you look at them, probably halfway through, the upper part will be something which we've seen for the last, I don't know, 2, 3, maybe even 4 decades. There is certain maturity in that upper part of the data landscape. Now, on the lower side, though, it's slightly different. We're actually still exploring and maturing those technologies. And if you look at the list, it has data virtualization, for example. Data virtualization is something relatively new. New in the sense not about the ideas. There's many ideas in computer science world which are very old. The implementation wasn't simply possible at the time of having that vision. Now, with data virtualization, for example, we actually we start seeing maturity in that space and mature offerings. Now, a few years back, big data shaken the whole space, data space, in the way of introducing not only big data, but also data streaming coming from Internet of Things, sensors, then unstructured data, which was something relatively new in that space, and NoSQL, which doesn't mean NoSQL, it means not only SQL, but this was actually a hashtag adopted by industry, but it means that it's not relational. And relational database management system have been served as very well for many years. And this whole trend in this space was a brand new trend, saying there's other ways of approaching data, and it's different than relational database management systems. Then definitely with the arrival of cloud, we start seeing cloud computing, and then processing getting closer to a data, and then data as a service also introduced in there. Now, since almost any new implementation tries to look at the cloud, if cloud could be a place for that new implementation to happen, there is a number of vendors who have a really mature offerings in that space, and it's still evolving. The data lakes is something which we truly welcome in the sense of inexpensive data storage. And when you look at those trends, those are later trends. They were basically driven by the group coming from this layer. The Hadoop brought lots of interesting ideas, and then vendors basically were catching up with the open source and trying to have the similar offerings in their spaces. Now, uh, data science, artificial intelligence, machine learning, which we're going to touch a little bit on. This is really exciting space, and the data plays crucial role in there. And we're going to look at machine learning later on a little bit, but not going to look at from the programming perspective. We're going to look at from the data viewpoint, and I'll show you what it means, what machine learning needs from data. And then with the data encryption algorithms maturing, the blockchain and Bitcoin introduced the concept of a blockchain, and then Bitcoin architecture got mimicked in cryptocurrency. And we also have something like dark data, but dark data always been with us. Dark data is data which usually companies collect but don't ever look at. So it sits in the dark corner somewhere. The interesting part is that so far we didn't have really good usage for dark data, and now with machine learning, this dark data could actually be a key differentiator for the companies which need a lot of training data. And we're going to touch on it later on, as I said. So this is just introduction of the data landscape. Don't think that this is a comprehensive view of it. I just wanted to make you aware that this landscape is still growing, and it's growing really rapidly. And those new ideas are popping like almost every other year. We see some new trends coming into the space. Now, as far as the architecture goes, we have a concept of enterprise architecture, and enterprise architecture is the Uber umbrella of all architectures. And data architecture is one of the four domains. When you start thinking about this purely from some kind of a very high level, when you look at the business architecture, this is something which encapsulates the business, how business operates, how business processes work, the relationships between them, any aspects of business is captured in this business architecture. Now, business usually interacts with data using the application layer. So this whole application layer, it's used to exchange data, either create data or read it back. And then the whole technology stack supports all of it at the top, all the other ones at the top. Now, this is a TOGAF definition. TOGAF, it's one of the Open Group Architecture Framework. It's one of the architectural frameworks which defines architecture in general sense in computer science. So I would probably encourage you to look into one of them, maybe not necessarily TOGAF, but get familiar with it. And if you have a look at the bottom of my presentation, I'm trying to include some relevant links in here. So you're going to get a copy of this presentation, I think the recording as well as the slides. So if you want to get a little bit more on it, or at least like I'm not giving you advanced topics in here. I'm giving you like some kind of starting topic. And as you see, Wikipedia provides lots of starting information. So you don't really have to wander too far these days. You can go to Wikipedia. In some cases, it's not very accurate, but it's a good start if you know very little or nothing about it, or you want to have some kind of stepping stone, which is going to introduce you to a bunch of new concepts in there. Now, as far as the data architecture definition goes, I was slightly struggling with it because I couldn't find the really good one. But as you can see, Wikipedia provided one. And I would say, as far as the definition goes, it's pretty good. I like it, and I'll explain why. because if you skip the definition for now and look at this diagram below, this is the data life cycle describing here. So we're starting usually with a data collection. We either create or collect the data. Then we go to the next stage, which is the storage of data. Then we're trying to integrate this data with already existing data. And then we're trying to arrange it. And we're doing all those activities in anticipation that the data will be used eventually. So now if you look in the reverse order to this data architecture concept defined in here, you will see that the data architecture is like almost like a logical representation of all those activities before you instantiate any component of it. So we have data models, we have policies, we have lots of rules and standards to help us to govern how the data is collected, stored, arranged, and integrated, and then eventually be organized in the way that it's the easiest way to use it. So I mentioned TOGAF. I mentioned that this is one of the architecture frameworks, and I think this is a different framework. This is called Zachman's framework, and John Zachman is very well known figure in software engineering because of this framework. He done lots of other work, but he's known for this. Very interesting individual, and maybe one of those days we can bring them to one of those SITACs meetings. That would be a treat for all of us. But John Zachman created this framework based on the real life approach. He shadowed his friend who was a civil architect, and he was trying to define the approach to architecture in general sense, regardless of what type of architecture it was. And then he took that all those methods and approaches and put it in this simple framework, simple in quotes. But this framework defines certain aspects of the architecture and development, which helps people to approach architecture, especially at any level, but especially on the levels which are enterprise level. Now, he broke it down into multiple columns, and you see one of them in here. And then this one, it has the viewpoint of data. And then he also has the perspectives, which are horizontal rows. And then when you look at this, you will see that each of them goes from the very top layer to the very bottom in the prescribed way, meaning that you start with a vision, which is in here. Then you take it to the next level, one level down with more details to the conceptual data model. Then from conceptual, you go to logical data model. Then you go to physical data model, and then you go to the scripts, which eventually will be instantiated, and that would be the enterprise layer. Now, each upper layer provides you a reference or a scope for the lower layer, and the lower layer will basically feed from the higher level and then get the next level of detail kind of exposed to you. The idea is that if, for example, you skip one of those models, you say, well, we don't need a logical data model, right? Then you have to compensate for it. So you know for a fact that you're trying to jump from here to here directly, or maybe even to implementation. Knowing that, you know that you're missing few important steps. Those important steps or areas which are not defined will have to be somehow compensated for the lack of detail. That means that you will have lots of assumptions, and those assumptions in most cases mean trouble because you'll be losing the previous context. So he defined it in this way that it helps you to work with it in the sense of defining the whole architecture. If you're not familiar with Zachman architecture or any architecture framework, I highly suggest you actually do this. So I'll stop in here for any questions before we move to data modeling. And Rakesh, any questions?
I have not seen any questions yet.
All right, any question from you?
No.
No, you've seen those presentations. Maybe you have generic question.
Nothing yet.
All right.
I'll just taking attendance right now
Yeah.
and just hearing the presentation.
Okay, so data architecture in general sense, I went through it very quickly. Why? Two things. I don't think that there is. You were already introduced to the architecture in general sense. I think Shrikan's presentation was about that. And then you're going to hear about architecture again and again, and most likely about some frameworks as well with any other presentation. Now, data architecture, it's no different. It also falls into some kind of architecture framework, and it goes from the very, very top, from visualization to implementation layer. And all those levels will be there. So that's a summary, right, of it. And this session will definitely won't make you a data architect, but the awareness of the prescribed method, it's important what you need to know. And then if you want to explore it, start with the John Zachman's framework. I think this is probably the easiest one to digest. And then you'll be on a good path to understand what it means in practice as well. And if you can use it in practice, that would be a testimony that you know what it means. And it's really helpful. And the funny story on the side, John Zachman actually developed this whole framework, and he documented it very well. But with the introduction of internet, someone defined this John Zachman's framework in Wikipedia, and someone told him, John, that it's defined and it doesn't look like that. Actually, it's representing his approach to architecture. So John Zachman himself, who developed it, who originated, who came up with this idea, basically went in there to Wikipedia and changed it. Basically, he rewrote the whole thing, and then a week later, someone changed it back. So he went back and changed it again, right? And then 2 weeks later, someone changed it back. So he gave up. He said, "Okay, I'm not going to fight with these people." But the funny part is that's the other aspect of the internet, that even he couldn't actually fix it, which I thought it was kind of interesting story. That story actually came from John Zachman. Now we're going to spend a little bit more time on data modeling. The pure reason for it is because you have deliveries in that space. Now, if you want more details, I would still encourage you to look at the last year presentation. Again, the link is on the first slide, because we spent a little bit more time in that space last year. But I'm still going to cover enough information and give you enough maybe links to the additional information that you can deliver those three parts, which are part of the data architecture in your delivery.
And I will also like to make a note that the past year presentation has been sent. The links to the past year presentation has been listed in the welcome packet too. So if you need all the presentation from past years, it should be in your welcome packet.
And that's a good point. I think most people actually missed that part. So I'm not quite sure why. Maybe it's a small print or something, but based on the answers which we got in the chat, actually nobody's seen it. So maybe next year we need to put a bit stress on it, that it would be good for students to look into it.
Yep. Absolutely.
Yeah. But nevertheless, I'm going to still cover enough so you have some kind of understanding what we're asking you to provide, and then how to start. Even if you're brand new to the data modeling part, I would still suggest that if you pay attention for the next 10-15 minutes in here, you'll be on a good path to fulfill those requirements. So don't feel like you have to watch it. I'm saying I spent more time on it. and since it's recorded and you have access to the recording and slides, I don't want to repeat it again like every year. But I'll give you the enough to actually have a good start. Even if you don't watch it at all, you'll be able to provide those requirements, fulfill those requirements. So when you've seen it from the Zachman's models, we basically started from some kind of vision and we were marching down to implementation through it. Now in here, you will see 3 different data models listed in here, which are the most common data models which you'll see regardless where you go. Especially in the places where they have established IT, established data space, you will see that all those models will be actually present. Now, when you start with the conceptual data model, which is the first here listed in here, this is the model which is the first kind of visual document which you review with your business. So this is your first interaction point after you talk to the business of documenting it for both sides, for business and IT. And this model is a common model describing on the very, very high level how business works from the data viewpoint perspective. So think about it. This is not a business processes. This is more like a how data is related to those processes and how the data entities are related to each other and so on. This is still very high level, so it doesn't have any lower level like attributes and detail level to allow you to implement it. But this is a starting point to have that discussion with business. The next level is the logical data model, and the logical data model, it's a detailed business solution. Basically, it describes the data structures from the logical level, in the sense that you will be able eventually take this logical model as an input to physical data model, which you're going to eventually forward engineer into scripts and instantiate in the database of your choice. But this logical data model is the last model which you're going to review with business. I never seen anyone who would actually review physical data models with business. There is too much physical implementation details for business to be concerned about. But business definitely needs to sign off your logical data model. This is very detailed one, describing every single data element which is part of the business. So this is how we look at it. So from conceptual, we basically move to logical, and from logical we move to physical, and physical usually is a forward engineering concept. If you're using like a modeling tool, it's out of the box. You just say my target database is Microsoft SQL Server, and therefore it's going to generate all the scripts in T-SQL for you. Or you're going to say my database, target database, it's Oracle. It's going to convert all your data types to proper Oracle data types, and it's going to give you those scripts in the PL SQL. And you can have a technical details in here, for example, in the physical data model, like indexes, constraints, which are specific to triggers, which are specific to the database system, and so on. But this flow, it's more important than anything else, right? So from your perspective, you still need to understand that it's not just an arbitrary list of models. Each model feeds from the higher level model, and each model, the previous model, help you to be more accurate in the lower model, and each lower model has more details specific to its own purpose. And again, if you have questions, post them in the chat. Now, this is I should go back. What you're going to be need to provide, as far as I remember, those two models: conceptual data model and logical data model. So the next slide, I basically listed the logical model and the physical data model, and slightly different naming convention for them. You don't have to worry much about that. It's just to know that in logical data model, entities are named different than in physical models, which we call them tables, and then attributes, we call them columns in physical data models, and there will be certain attributes which we're not going to have in the logical model. For example, indexes, partitioning, and so on. Usually you don't have it, right? If you do have them in a logical model, that means you have a special case for it. Now, I also showed you on the other one what kind of expectation is from each model. And again, in some cases, you may actually see that a conceptual model has some attributes, maybe key attributes listed in there, but usually from the purely from the implementation, it has to have at least that kind of level of detail which is listed in here. So that may help you to navigate through it. Now, this is one of the conceptual data models which I kind of borrow from one of the previous templates from I believe a previous year or maybe a year before. I'll go through. So this is a conceptual data model, and this conceptual data model, the whole thing, it's about a business process which is about order. So let's say this is an online order. Now, what you have in here, you will have entities. All these boxes, like this box in here, the order box, it's basically called entity. Those entities will have some kind of relationship between, and this line connecting them it's that relationship. Each relationship will be also defined by some kind of a description in here. Now, as you can see, customer, in this case, it says has order, customer can place orders, or customer basically creates those orders. So this is the relationship between a customer entity and order entity. And entities are representation of logical representation of physical objects in our world. It's like if you know object-oriented programming, it's a similar concept. An object could be a person, a place, a thing. That's the concept of an entity as well in here. Now, the entities, on the other hand, are a data construct. So they will be encapsulating all the details related to the data. Now, when you look at this model, you'll see that the customer places an order. An order is basically fulfilled by inventory. So definitely you need some kind of link to inventory to see if you even have those items. Now, when customer places an order, most likely customer will be looking at some kind of offering sitting in the product catalog. And then when the customer is ready to say, yes, I want to buy it, the invoice will be generated for that order, and then an order will be scheduled for shipment. And as soon as it's actually the shipment is received, the tracking number will be created, and then you see the whole flow in here. So in general sense, what you're describing in this whole model, it's a business process, but business process from the perspective of a data flow. Sorry about that. From the data viewpoint. Now, as I mentioned before, this is the first model which you're going to check with business, and you're going to start asking hard questions to business, right? You're going to say, well, is this model accurate? Is this model accurate that that your shipment, it's a single shipment, for example, right? How the tracking system works. Is the invoice correct? Do we have any other players in the invoice? Do we have, is it internal process? Is it external? And they will correct you in the things, not only by those entities, missing entities, maybe something is missing in here in the whole process, right? They will also tell you if those relationships actually are done this way or the other way around. Maybe they will say that that the order usually goes to the product catalog, and product catalog has a lookup to in the inventory, and it hides all the items from the in the product catalog if in inventory it's 0, right? And then maybe this relationship doesn't exist directly. But that's the type of discussion you'll have here with your business to validate if this model is correct or not. And if you look at the some kind of part in here, which I listed in here, the most important things is first, you actually build the understanding of this business process from the data perspective. Now, you take this model to business and then define the scope. So if you're missing something, the business will point it out and you will add it to your scope, right? And then you also can say, well, if we're going to replace the invoice component, which is in-house, with some kind of third party, how this is going to affect us. So you can also do the initial impact analysis based on this model. And then, so some kind of proactive analysis. And then, as I mentioned before, this is your opportunity to talk to business and build that rapport between business and IT. And then open the communication channels where you can discuss what you're going to build, and business will be able to give you an early input on it. Now, I borrowed this model as well from the previous year. By the way, none of these models is perfect, and it's I assume it's on purpose, so we can discuss them. But in this model, what's different between these two is that you can see that the detail level is slightly different. In here, you will see an entity like an order, and when I switch to logical, you will see that order now got number of attributes. So logical data model supposed to have all the attributes which are relevant to that entity. So order, you will see that there's some kind of dots in here. Maybe you won't be able to see it, but there's a bunch of dots in here. This is usually your modeling tool, which is going to tell you that there's more attributes in here just from visual perspective to put all those boxes together. It's just from real estate perspective, they're hidden. But the idea is that this table will be large and this entity will be fully attributed, meaning it will have all these attributes in here. And then from the requirement perspective is that you fully attribute your order. So you go back and forth with your business, and based on that, you'll see if you're missing something. So if you look at the customer, for example, at the top, right, I have it in here, you will notice right away that what you have some kind of information which is specific to customer, like a ID, membership ID, first name, last name, maybe some kind of additional information. But then based on this model, assuming this is a full model, doesn't have additional attributes which I mentioned in here, you will see right away that you won't be able to ship this order to customer because there's no customer address. So that's an obvious thing, right? You missed something. Oh, I missed the whole address part, right? So you know that this is not not fully attributed model, and that goes back to the initial statement that this is your communication tool, and this is the first audience will be your business. The next audience will be your IT. So this model is a tangible bridge between business and IT, because IT it's not going to make this model more accurate from business perspective than this model is. The physical model most likely is going to be instantiated based on all the attributes in here. There's the choices of the database management system, but as far as the business representation, this model defines that. So this model is extremely, extremely important to have. Actually more important than physical, because there's many tools which will take this model and then convert that to the very like a rough draft of physical model, and then you can just correct few things in there and forward engineer that model. Versus on the other hand side, if you have your physical model, most likely you're going to miss that discussion and discovery sessions with the business, and business will never be able to digest the physical model as well as this one. Now, this magic in here with those entities and attributes belonging to the proper entities, and then relationships between them, it's not something which you basically put on paper right from the start. Usually what you do, you start with the list of attributes, and then you group them together in some kind of way that they belong to to the same group, and then that group will become a customer. Maybe this group will become an order, and so on. There's a prescribed way of building this model. We call this prescribed way normalization, and normalizing is that process of creating this model. And normalization ensures that this model is it's built in the way that it will avoid certain data anomalies. Now, we go through the normalization process, which brings this model to the first normal form or second normal form, usually to the third normal form. That's our ultimate goal, although there's a fourth and fifth and so on. The third normal form, usually it's good enough to represent everything in a way that it's clean and you can actually communicate that with business. Now, those relationships in here, which are in here, they also are very specific, and there's a specific notation which I have in here, which you can look at, and this notation is which is included in here. It's one of many. So the part which is important is that if you include some kind of notation, make sure that you have some kind of legend for it. The most famous one, it's IEEE, which is also known as a crowfit, because it has this weird notation here, which looks like a crowfit. But the idea is that any notation which you use, it has to be visual to the point that business can understand that, because you're going to communicate that to business. Professionals like IT professionals, they will learn any notation. Easier notation for business means that easier communication to business. Business will be able to spot all those mistakes which you made in here with the relationship and so on. So this will be way easier for you if you choose a notation which is easier to digest. And since you're new to this page, or most of you are new to this page, find a notation which is easier for you to understand without actually learning about that. Now, when you look at this model, you can also assess how good this model is, and you can do this yourself. You don't have to actually wait for the SITAC judges to tell you about that. You can definitely do a good job by looking at those few things in here. Now, the first bullet is capture requirements, right? So you go through the requirements, and you already have those requirements. You already have user stories and so on. So you know what you need to deliver. But purely on that, even if you compare those two models, so I have this a conceptual data model in here, and you see I have a concept of invoice in here, and you look at this one, and you see that there's no invoice captured anywhere, you will notice right away that there's something missing in here, right? The invoice is not here. So definitely this model doesn't capture all the requirements, because this one is missing for the invoice. Definitely needs to represent the business. So that business validation needs to happen, and usually this model doesn't happen on its own. Usually the starting point, it's a business interaction, and then the model gets created. So this would be like a second step, not the first step. First step, it's interview with the business. Then naming standards. If you look at the naming standards, and let's examine a few of them, just on a high level, you will see that this naming standard actually doesn't exist in here, or at least they broke it. The customer ID is spelled lowercase customer, uppercase ID, no space. This one, on the other hand, has order and a space and an ID. So you don't see the consistency. You see the spaces, you see underscores in here. So come up with one naming standard and follow it. For the logical data model, the best approach would be use business names, use spaces, use the names which business is using. You can generalize them, but don't use like a very cryptic abbreviations which nobody truly understands, because that wouldn't be good. Like you see that here, customer ID, it's spelled cust space ID versus customer ID, and here it's different, and so on. So you try to be consistent. So the naming standards are important. Good definitions. Each of those entities will have to have a definition. And the definition is something which comes from business. So you sit with business and ask them, what does it mean to you when you name someone customer? If you have a membership, is a member a customer uh, as soon as that member gets his member ID? Or the member becomes a customer when she places her first order? And that's the business question. It's not IT interpreting that. It's business question. It's question to a business. Business will be able to tell you what it is. And that's how you basically create a definition, which is meaningful definition for a customer. You translate what every business said, you encapsulate that, and you put that into a definition of this entity, customer entity. And the same goes to every single attribute. Each attribute needs its own definition, and that definition should come from a business. And if business doesn't have a concept of a customer ID, this could be like, influence from software engineers who think, wow, we need a customer ID, we need surrogate key. That may not be reflected in here. It depends on organization. Some organizations, they don't have surrogate keys in the logical data model. They have just natural keys coming from business. But that's a discussion with business. If business has a concept of customer ID, you do have a customer ID in here. If business doesn't have, that depends on your standards in your own company. And then definitely arrange for readability. As you can see, this is relatively easy to digest, this model, uh, uh, because it doesn't have many entities. When you, in the real world, most likely you won't have like just a handful of entities, you'll probably have more of them. Sometimes you organize them in a subject area, so it's easier to digest, but it's not unusual that you have probably a dozen or maybe even more entities in your logical model. And at that point, organizing these entities around, so the relationships are visible, they actually point, they don't cross, they don't overlap. It's not like this relationship merges with this one and you don't know what it is anymore, and so on. It's not like you have overlapping entities, so you don't see what's in there and all that stuff. That's the readability. So you can walk your business through this model in some kind of fashion, showing them this flow of the data which relates to their business processes. So
We have some questions.
yeah. So before I go to questions, or maybe let's go for questions first.
Okay, we have a question from John. He's asking, is data model same as the database model?
So depends which data model you're talking about. So let me go back in the slides and show you the Zachman's model. I'll just clear it. So when you look at this model, right, you will see that that this will be a conceptual data model in here. This will be your logical data model. This will be your physical data model. So the physical is the closest to what's going to be implemented in your database. So most people, when they talk about the database model, they talk about physical data model. Is that 100% true? May not be, but this is the closest model which will be referenced to your database model. So there's a concept of forward engineering. Basically, if I have this model to begin with, and I have the right tools, and those tools exist, there's many tools on the market, I can take this model and basically generate the scripts which are in here, DDL scripts, data definition language scripts, which will allow me to instantiate all these tables and columns and relationships and constraints and indexes in the database. Now, you can do the reverse, which is called reverse engineered database model. If you don't have a data model, physical data model, you can go to your database and basically use this tool, and this tool is going to read all the schema information and is going to create this physical data model. Unfortunately, you can't recreate out of the physical, you cannot go back and recreate logical, and you cannot go back and recreate conceptual. Usually it's the other way around. Plus, you see what the problem is going to be, that you at this point, if you've done that, you'll be basically bypassing the business input. You'll be driving the logical and conceptual data model from physical implementation. I would say you could probably I seen it many times that you will reverse the physical database and then come up with the physical data model, but you don't go beyond that. So the closest one to answer your question would be the physical data model, but the other ones are not considered as a database model. Plus, with the newest technology right now, and we used to have relational database management systems. Now with the value pair databases which have different concepts of storing data, maybe like document databases, for example. Then what you usually do, you still go through conceptual to logical data model, and then you you're you will basically won't be able to even reverse engineer beyond that. So even if you had your physical, the physical will be just a value keeper. You will never be able to recreate logical. That's the most important part. That logical is so important because this truly encapsulates the business. And from this NoSQL databases schema on the right, it's extremely difficult to derive a proper model out of it. So this is a caution. Try not to do this. But in short answer to your question, John, will be that physical data model is probably the closest interpretation what you should have in a database. If you have a good IT practices, then yes, that would be true.
Great. So it's not a question. He has a follow-up comment. So he said, okay, so physical model is a really good outline for a database model and can be used to generate one, but they aren't exactly the same.
Well, let me clarify that. In a perfect world, they will be exactly the same in a sense of they will represent the same information. Unfortunately, we never live in a perfect world. So I'll give you an example. If you have a very good IT defined processes and your process says you cannot instantiate anything in production unless it's derived from the physical data model, and you have a process where your physical data model will be forward engineered, and then those scripts will be automatically deployed in your production environment, which is doable. I've seen it in practice at Microsoft, for example. Then that means that your data model, your physical data model, will be a representation of what you have in a database, because that you will not be able to create objects in a database even if you had permissions to do it. Meaning you will be able to create them, but they will be detected most likely by the process, which is trying to see this if your database is in sync with your last checked in and golden version of your model, and it's going to drop them. So that's the automation which you can actually go forward with, and the automated process will detect the foreign objects which shouldn't be in this database. It's going to basically drop them, thinking that they're basically artifacts from the older version of the model. So if you have that process in place, then your physical data model is truly representing of what's in your database. But those two concepts are slightly different. One is a data model, the other one is a database. It's a physical implementation of that data model. The data model is still logical. It's still kind of a logical construct, although we call it a physical data model. It's still a model. And now instantiation of this model in a database, it's a database which can take data and so on. But good question.
Great, thank you. So he said, cool, thanks. We have another question from Vaibhav. Is it needed to have data type against the attributes shown in the logical data model, or just the identification of keys is enough?
So you do need data types, but if you're a software engineer or a programmer and you're already introduced to the data types based on the language, you know that those data types differ per language, and it's the same in the data world. Those data types will differ per your database management system. So for example, Oracle has a very specific data types related to date and time. Same for Microsoft SQL Server. HANA, SAP HANA has its own data types as well. So each vendor will have, although all of them are compliant with the SQL 92 standard, they still have some kind of variations because they want to extend that standard. So they want to extend their database capabilities to be able to handle more difficult data types. So they will have those specific ones. So what you're aiming in the logical data model, you're aiming at defining those data types on a very, very high level, which is database agnostic. And usually if you have a good tool, those data types will be defined relatively well. Maybe in this example, when you look at for example, when you look at let me see if I can actually zoom in. When you look at the customer, for example, you will see that they have a very specific data types in here. I would say this is slightly fake because usually you could go to this extent, but I don't think you have to go to this extent in your delivery, and I could be wrong, so check with your mentor. But ideal scenario would be that you identify that yes, customer ID, it's a number, or even go farther, it's an integer. But most likely in your logical data model, if you have a good IT practice, you will have a customer already defined in the concept of a data type, and that concept of a data type will be slightly different than a truly physical database type. We call it domain. We associate those data types underneath of the domain, and then when you take this logical data model and forward engineer that to the target database physical, it will convert all those data types to the proper one, and at that point it will actually become integer, right? Or it will become a varchar, and so on. But you cannot be wrong in your exercise if you specify them. If you go one notch up, saying that this is numeric value, customer ID, it's a numeric value, a membership ID, it's still numeric value, but you won't specify the length of those fields, you'll be still good. And the same about varchar. If you say that it's a string or a character based, you're good. So go back to what data types you understand and don't overdo it, but at the same time define them. So yes, they will be needed.
Great. He said thanks a lot. So we have one more question. So this question is from Vivek, and he said, is normalization required for logical data model? Is a normalization only applicable to relational data?
This is an excellent question because your generation more or less didn't grow up on relational database management system. You're exposed to different database management systems, and different it's in quote because more or less the goal is the same, serve this data to the users, right, in the best way possible. But the problem with the thinking of skipping this model and normalizing this model will be you won't be able to communicate that with your business. So if I go back to the Zachman framework, you need to understand the flow of what we're trying to do, right? So if you're going to create some kind of a logical model, which let's say it's closer represents your database of choice, which is some kind of NoSQL database based on a key value pair, then it will be extremely difficult to show that customer ID number, it's how it relates to anything else. In my opinion, and I think this is, unless you find a better way and then sell it to the world, the only way of doing it right will be through normalization system. Now the question would be, do you want to go up to third normal form, or you stop at a certain level of the normalized data? We aiming at third normal form usually because we want to know that we got this model to the level which is deployable, which can be instantiated. Now, what we do in some cases, we step back and say, well, instead of presenting this in the first normal form, business would benefit more if you actually have it in a denormalized form. But as far as the exercise goes, you go to first normal form and then you fall back. You don't stop at the lower level and then just say that's good enough. So I would still suggest that you go through normalization process and still for logical model, not for physical, because physical could be it could be non-relational, right? Then you go through normalization process and you still actually learn this process. This process is something which I don't think it's going to disappear unless AI is going to start building those models and databases for us, and therefore we wouldn't have to do anything, just talk to the machines. But until that day, I would say learn it, and yes, do it in the proper way.
He said thanks.
You're welcome. Any other questions?
No.
All right. So what I put in here, I put a bunch of different links in here. I was trying to address few things which you're going to be challenged with. Well, those, and I suggest you go through all of them. And the reason is because they're very short. In most cases, they're 5 to 15 minutes reading. Some of them are videos, so you just sip some coffee and watch it. But that would give you enough information to deliver those two models which we're asking you to deliver. And the first one is identify entities. I have a link to it as well. So I'm starting with like the first one, which is basically, do I really need data modeling, right? That would help you to understand why we're doing it and what's the value of it, in addition to what I already mentioned. Now, identifying entities, it's one of your deliveries, so definitely pay attention to this one. This one walks you through some kind of short scenarios and shows you, oh, this is an entity, how to identify them, and then you'll be able to walk through your user stories and basically identify those entities. And as soon as you have those identities, watch this guy. I think this is still reading, not a video, but read this one, because this one basically tells you, okay, you identify entities, how you put them together into some kind of a data model, which you'll be able to instantiate eventually as a database. And I also have a tiny reading about the naming convention. In a database modeling, I mentioned that has to be some kind of a consistent way of approaching it. Again, those are small readings, probably like five minutes. And then notation, which I also mentioned, is important because you have to decide which one you're going to adopt. And this one is a very easy way to I think it's a reading, maybe 5-minute reading, so you can spare that amount of time and save yourself lots of trouble. And then I have this section at the database design 101, and I think the last link is actually a video. So if you watch this video, it will be easy for you to actually even understand the flow and then follow it. So you can even start with this video and then go back to each of the sections, and then watch it again at the end. So that would be my approach to you learning it from nothing, basically not knowing anything about the data, how to build a data model, and then by going through these links, you should be in a good position to start building it. And as soon as you build it, review it with your mentor. Your mentor will tell you if you're on the right path or not. And if you get stuck, talk to your mentor. Your mentors will be able to help you to navigate through the space. This is not an easy start. This is pretty steep learning curve, and it will be probably not very natural for most of you. Some of you are going to thrive, but some of you are going to suffer in here. So I would suggest go through those links first. Try to build something, and then talk to your mentor. So your mentor at least has something. Doesn't have to explain every single basic thing for you. You already have some knowledge what it is, and mentor will help you to put it together into a consistent way, and then have those 3 deliveries artifacts created for your delivery, for the next delivery. Any new questions before I move to the next section?
I don't see any question.
Okay.
I think we can move on. Yeah.
So, uh, so this was my in all those three data related topics. This was my focus because I know you have delivery in this space. But I'm going to also touch on data patterns now. So the data patterns is something which I think it's important to understand that they exist. Maybe not necessarily knowing all of them or learning all of them, but it's good idea for you to know that they exist and take advantage of them instead of you struggling with some kind of uh, reinventing the wheel. And that's the whole idea behind it. So this is something which I introduced last year, so I borrowed it from last year, but this pattern is probably the most recognizable pattern in the form of a pyramid. And the pyramid, the idea of the pyramid, it's multiple level. First, that you start from the bottom. That's how you build the pyramid, and you go up. And then the volume of what you have in here will be less on the next one, and you will be a little on the top. That's the whole idea behind the pyramid as far as the shape goes. Now, there are some people who are going to look at this pyramid and argue about it. There's religious wars, white papers written about that. So we're not targeting that audience. We're just trying to understand the basics. How a simple data, which we capture in our operational systems, uh, what's this data journey to become intelligence? And that's the main concept or a pattern here. And in the data space, think about this way. The data, we generate lots of data, especially now these days. Everything generates data. Lots of data. Even if you have traditional systems, like you have a retail system like a Costco, uh, we generate about 5 million transactions every single day. Now, if you take the line items, then we probably have and put it in the relational database, will probably be about 100 million rows every single day. So just imagine this type of volume we give to business directly and say, okay, business, you want to see how your business is working? Here you go, 100 million rows. You have a couple of hours to make your decision. So the next day, you actually start making money, right? So what we usually do, we try to organize this raw data in the way that business will be able to make decisions. So what we do, we take this data, we take this sales data, for example, and we put it in a specific context. And the context is driven by business. So business will have different viewpoints. Like finance will be looking at the profit and loss. Supply chain is going to look from the maybe inventory perspective, right? The people who decide which products to introduce or which products to deprecate, they're going to look at the maybe at the interest, or maybe something which having this product leads buyers to buy another product, and that's a basket analysis, and so on, so on, so on. So there will be different viewpoints from business, which is not just one view. Business will have multiple views in how they want to see this data. So when data becomes information, we take this data, which is in the simplest form is just a fact and meaning, and then we put it in the context of the business, and now we're creating those viewpoints. So we organize this data in that way. So what do we do? We organize this data, for example, in my example before, we organize it by location. So, America will have its own location, like US, Canada, Mexico, and then each of them will break per region and then maybe per store. And then you can see that the store made, I don't know, $1 million, like, and you can compare that with the previous date, which was 1.5 million. And you know that you actually made less today, right? So then you can investigate that. Maybe that's really interesting. Why, right? And today actually it was a snow day. There was no many customers in the store, so you can take additional information in here and basically plug it in and give them additional view on the top of it, which would be affecting their data. And that's what you're trying to do in this information stage. So from the raw data, you try to bring it to the level of information. And then what business does, business takes this information, which is already organized in the way they're used to see it, and then they understand what it means. So they understand what those numbers mean, aggregated in comparison to the previous one. What you visualize the data, you give them some kind of charts which tells them what it means, and they know how to interpret those diagrams. They know how to drill down to the information which they need, and then based on their business knowledge, they will actually start making decisions, because the idea is that the intelligence, it's a combination of information and humans. At least it used to be before AI arrived, right? But this used to be this whole intelligence concept was very, very linked to the humans interpreting information, and then based on their experience, they are able to merge experience with the information, and then they will be able to make some kind of strategic decisions. Are we going to drop this product because we don't make any money and it's not bringing additional revenue from the related products? Are we going to change anything in our business? Why are we losing money? Why are we making money? Can we make it better? Is there any large amount of something which we're losing money through the some kind of aspects of the business they understand very well, and they have information which supports that decision. So what we're trying to do, we're trying to match a few things in here. We're trying to instead of business making decisions on the sixth sense, we're trying to give them that information which they know how to interpret, and help them to either say that the sixth sense was correct, or basically bypass the sixth sense if we have a better way of showing that relying on this information is better than sixth sense. And in some cases, sixth sense still works very well, but moving forward, there will be less and less time to develop it. So we want to create this model which will help business to make those decisions, and informed decisions. So this is why this pattern is so important, how data actually becomes information, and then how it becomes intelligence. Now, as I mentioned, this used to be humans domain. Now AI actually start looking into it, and AI it's a tough competitor in this space. So I think we're going to see that AI is going to surpass a human sixth sense, especially when we're talking about those millions rows of data, which needs to be interpreted in so many ways, plus additional aspects coming from different variables. Like today, I mentioned weather was one of those attributes, but whether it's visible, the other may not be as visible, especially in a small region scale. Now, this is another data pattern which is very, very well known, and it's a traditional relational database management system workflow, where we basically starting with the operational system, and then we take the data to something which we call data warehouse. We organize it in the way that it could be analyzed, and then we present it to business in a reporting fashion, visual plus data. So if you go back to this model, this is what we're trying to give business. We're trying to convert this data to information in the context which is specific to the user. That's what we're trying to do in this pattern. This is a little bit more tangible. This is how we have components like data warehouse. We have analytical capabilities like analytical tools. We have BI tools which help us to visualize this data and give this data in a predefined format, pre-aggregated, and then with the ability to drill down and drill through. And the whole process of getting from the operational system to organize this data in a way that it will be used for business to make business decisions, we basically have a pattern for it. Now, this could be different tools, and you will see that the new approaches in a data space kind of have lots of offerings in here. The same in here. Sometimes one of them could be bypassed and you go directly in here. Sometimes you can do operational reports directly from operational system through BI tools in here, like Tableau can connect to your operational data. Even Excel spreadsheet can do it. They have in-memory functionality, which allows you to aggregate lots of data in memory. So they have those capabilities. We also have a concept of the data movement, which we call ETL, which is extract, transform, and load. We extract the data from operational system, we transform it on the fly, we land it in a data warehouse, and then we try to actually walk through the additional aspects of it before we visualize it to business. Now, this is just a tiny difference between these two. So I mentioned extract, transform, and load. So this is basically the flow: extract, transform, and load. This is usually how you go through it. Now, right now, we're trying to bring the processing closer to data. So we try to use the ELT. So this term in here, extract, load the data to the database, and then bring processing or transformation to where the data is already residing. So basically do this in place. But this is just the performance optimization. It doesn't change much of anything else. The flow is still more or less the same. So you don't have to argue about this, but if you hear ETL versus ELT, and again, religious wars around that, at least you know what it is. Now, as you can see, this is big data workflow, and it doesn't change much. It's just slightly different naming. There is a data ingestion, data processing, and data storage, and then you have machine learning involved in here. You still have BI aspect of it, and then you have, like in here, you have a message queue. You have your data streaming, and you have some storage, and in here you have IoT, Hadoop, and Cosmos database, and then machine learning to try to find interesting patterns, and then exposing that through the BI tools to user. More or less the same flow, as long as you know what we're trying to do. We're usually touching on the operational systems, which generate lots of data, like I mentioned, like retail sales, and then you bring it, you try to ingest this data, process this data, then definitely you need to store it somewhere. You could have in-memory storages, so don't think that it has to be stored physically. And then you process this data, and then you do some kind of visualization for that, so at least your business can be productive. But because we change technology doesn't mean that we change the patterns drastically changed. And I have this one, by the way, I put a link in here at the bottom. You can actually see that there's lots of other interesting concepts in here. All those slides with data patterns came from this data guide. So if you're interested in the more patterns, just look in there. I was just trying to show you that those patterns, although technology changed, those patterns didn't change. And even if you decide to skip one of them in the middle, doesn't really matter much, because you're aware of the pattern and you're doing it because either the tool is mature to do it, or your scenario, what you're trying to address, it's allows you to do. But the typical patterns actually still hold. So regardless of the new technology arriving every year. Now, this slide is actually from Amazon. If you look at this one, it has offerings which are available in Amazon. Doesn't mean that all of them are written by Amazon, but they're available in Amazon. What I wanted to stress again is that you still have the same kind of pattern in here, that you have basically collect the data coming from various systems, you store it, you analyze it, right, and you expose it to your consumers, right? So again, very, very similar patterns. Actually, I would say it's identical pattern. It's just different naming, different tools underneath of it. What I like this slide for, it's slightly different thing for that. In here, when you see the sources, you see the different type of sources. So you see application, you see logging, and you see IoT, Internet of Things, and they create data, different data, and they basically create this data in a different format. So IoT usually creates a lot. This is data coming from sensors. So the sensors produce lots of data, and then the how you're going to store it. It's probably slightly different than how you're going to store data coming from applications. Logging usually gives you some kind of a logs at the point of time. Either it's every 5 minutes or minute or a day. So you have a slightly different ingestion process. Maybe you have a little bit more towards batch process. This could be with IoT. Usually when you monitor something, let's say you monitor some kind of industrial fridges, the temperature in them, you will like to know at which point the fridge start failing, not after the fact, like one day after. You want to see it close to real time. So that would be slightly different processing of this data versus in here. Maybe you just have your web application which collects that logging information, and every 5 minutes or 10 minutes or 15 minutes or an hour, whatever your scenario is, you can actually ingest that. And the same is about application. And then you look at the store, and the store is also it's going to align with your type of the data which you're ingesting, right? So you see that it also has a slightly different concepts of how this data is going to be stored, right? And you can see also the concept of cold and hot data. The cold is usually associated with the data which is not used frequently, very seldom. Usually it's kind of like a type of a backup, data backup. And then you go to hot, meaning that this data usually sits in memory, some kind of structures in memory, because you want this data to be accessible at any point of time. And then you see the similar concept of the warm, which is between and hot again. So pay attention to the source, what type of source you have in here, then organize it in a proper store, which is applicable to this type of data. Then think about the data usage and data retention. Do you need to introduce more than one data stores, cold and maybe hot, and maybe warm? It's not needed for your scenario, but at least cold, which is usually related to money, right? Hot will be very expensive, right? And then cold will be less expensive. So you want to lower the price of whatever you have implemented in cloud. That would be your type of thinking. And then you have analytical tools which could be specific to stream processing, like in here, or or batch processing, or interactive. And then you have also machine learning, right? And then you have a bunch of tools which allow you to create some kind of visualization of this data in the format that humans can digest that and make decisions based on it. And again, you have a concept of a fast in this case and slow. Fast means usually you want to get that information close to real time. Slow, you have some kind of delay, and the delay depends on the scenario. So what I added in here is it's a tiny thing, basically a data management system based on NoSQL database, and then a columnar data store, what it's good for, key value, graph database, document database. This is just informational, but if you start looking at this, you'll see that, for example, SAP HANA is relational, but it's shown in here because it has a columnar data base capabilities. The same about Oracle, the same about basically most of the modern systems. They will have the extensions which allow you to deal with the big data, NoSQL data. I want to mention this because this is a cloud design patterns. Sometimes you are under the impression that as soon as you put your application in cloud, you don't have to worry about it, and that's probably cloud marketing department, vendors department, which is going to convince you about that. But you have to worry about those challenges, and you should probably look at them. Look at this link. They actually have definitions for all of them, so that would help you to navigate what's important, what's not. Questions for this section? I know I went through it quickly, but you can go back to the previous presentation. I spent a little bit more time, or read that link which I provided you. Any questions?
I don't see any questions.
All right. So we're going to move to a fun part. Those last two are going to be fun part. I hope for most of you.
I am
So
excited.
good. We're going to start with machine learning, and we're going to end up with the topic on cryptocurrency. Well, when you think about machine learning, some of you, depending on your personality, is probably going to look at the future looking like this, or maybe like this. I don't know. It's up to you. I'm not going to tell you how the future is going to look like because I don't know. I'll show you some trends though, and some facts, and then you'll see the direction, and you can make a decision for yourself.
However, I like both movies.
But not as the outcome, right?
No, not at the outcome. Yes.
Right. You don't want to see this in 10 years from now, right?
No.
All right. So when we talk about machine learning, unfortunately, there's weird terms which are associated with it. I don't want to explain any of them in a way that it will take too long. But in a sense, I just wanted to touch on a couple of things because we're kind of misled by a long history that humans are so special and this cognitive processing is related, it's only reserved for us. So the cognition is mental action of process of acquiring knowledge, understanding through thought, experience, and the senses. Just keep that in mind because so far we thought that we're the only species which can do it. So now, along those lines, we thought that we're so special that we said we're so superior to anything. There will be no way of creating some kind of artificial intelligence or intelligence in general sense, which is greater than us. And we used this example for a very, very long time as a testament that we are so special. It's a chess game, which is looks very simple. It's just 64 squares, right? But why it's so special, right? The special comes from the possibilities. So if you look at those numbers, I have number of legal positions in chess 10 to the power of 43, and the game tree complexity 10 to the power of 123. And how big are those numbers? In comparison, number of stars in the universe 10 to 23, number of atoms in the universe 10 to 80. That should give you some kind of ability to compare those numbers. That's why chess was so special. It was extremely difficult to create a machine which would be able to have ability to digest all these possible moves and train that machine in that way that it's going to use it in a timely fashion to compete with people. Well, as you know, in 1997, IBM Deep Blue, which was a special purpose-built supercomputer, played against Garry Kasparov. And Garry Kasparov is not just one of those chess grandmasters at the time. Garry Kasparov at that time, I don't remember exact number, but I think it was like 12 years or 14 years. He was a grandmaster who never lost a match. He lost games, but never lost a chess match. Now, in 1997, he played against the Blue Deep, and IBM Deep Blue won it. So if you can see in the background, that's Garry Kasparov, and he was devastated. Not because not only because he lost the first chess match in his professional life as a chess grandmaster, but he lost to a machine. How ironic it was that. And he promised after that, he promised that he would never play against machine again. And he actually kept his promise. What he done though, he started using computers to improve his game. Now, let's fast forward to 2017, so 20 years later. Machines don't play with humans anymore. Humans are not good opponents to machines. Machines play against machines now. So Stockfish 8. Stockfish 8 is the top chess engine, which is at that time, I think in 2016 was a number one, winning with everyone. So Stockfish 8 plays against AlphaZero, and AlphaZero, it's a machine learning algorithm developed by DeepMind. And DeepMind, it's the organization under Alphabet, so basically a spin-off of Google, led by Ray Kurzweil. And if you don't know who Ray Kurzweil is, he's like a legend in predicting uh, uh, what's going to happen in the future. He's actually good at that. He has a good track record for that. So if you don't know Ray Kurzweil, search for him. He has a number of books. Read those books are actually good. You should read at least one or two. But he's leading the DeepMind, and they developed the algorithm for AlphaZero to play chess. And AlphaZero defeated Stockfish 8. AlphaZero won 28 games, 72 draws, did not lose a single game. And you may think, well, it's just a machine versus machine, new champion, and so on, right? But there's a slight difference in here. Stockfish 8, it's basically built on some kind of way which we thought about computers. I don't know. It goes back probably to 60s. The expert system. The expert system is a system which has access to the very, very large database. Basically, the Stockfish relies on the 20 years of every single machine-to-machine game, a chess game, and then recording every single move and potential patterns to win from a certain scenario. The same centuries of data which was recorded between human chess players, and then keeps that in a database, and then has extreme power of 70 million positions per second to reference this data and come up with the best move. Now, AlphaZero is just a machine learning algorithm. Its processing power, it's only 80,000 moves, only in quotes. But in comparison, you see that there's a huge difference. And it has a special built hardware, which is accelerator. It uses a tensor processing unit. It's like a GPU, graphical processing unit. But the interesting part is not that. The interesting part is that bottom part. It has no library of those moves, and it learned the game just by the algorithm was given chess rules, and it played with itself. It played against itself for 8 hours, and then it beat the champion. So basically, from nothing, from zero, 8 hours later, it became the best in chess. Just imagine yourself, you're waking up tomorrow morning, you're picking up one of those books, I don't know, quantum physics, and you become the best in the world in 8 hours. That's the kind of idea behind it. And the interesting part is in here that this AlphaZero didn't actually didn't read any books. It just got a concept, and then based on the rules, it created its own moves. And the most interesting part is that AlphaZero played in such an orthodox way that right now, when chess players, like we still have chess matches, humans versus human, when one of the chess players has a very unusual move, then it's scrutinized for maybe it was helped by a machine. So it's reversed. Machines are actually better in whatever we used to be the best at now. So this resonated with me. This picture resonated with me. I'm thinking, finally, we're able to create artificial intelligence, and we humans done it, right? And this picture actually resonated with me for this reason. For this reason, because this picture is a very famous picture. This is the Michelangelo's fresco in Sistine Chapel in Vatican. If you haven't been there, highly encourage you to go in there. And this is considered as a cornerstone work of high Renaissance art. So this is just one panel. There's multiple panels in there, but the whole project is regarded as one of the major artistic accomplishment of human civilization. So I took this picture from Wikipedia, and as I was dropping in the PowerPoint presentation, the PowerPoint presentation basically gave me this pop-up and saying, automatic alt text. We added alt text to describe your image for people with vision impairments. And look at what they added. They said alt text, a picture containing sitting, foot, laying, and table. So the major artistic accomplishment of human civilization was reduced by AI to a picture containing sitting, foot, laying, and table. So in defense of AI, this is Microsoft AI, right? So maybe Google AI, it's better. But there's still hope that maybe AI won't take all our jobs, and there will be still room for us, for humans, to provide some value. Now, I mentioned to you that I'm going to look at the machine learning from the data perspective. So those challenges which I have in here are related to lots of data. Now, typically, and that's not true for everything, right? Typically, to create a good algorithm, you need to train a model, and the model needs more data, lots of data. More data you have, most likely more accurate that algorithm is going to be. So lots of data, and this is not just any data. The data has to be well prepared. It has to be clean data. So all those things which I mentioned before about ingestion of the data, transforming this data, cleansing, going through the data warehouse, and all that stuff, it's still not going to disappear, because you still need first lots of data, and then preparation of this data. It's important, and then definitely something which cloud has ability to big data stores, because you need to have access to this, direct access to this big data store. And then if you think about cloud computing, especially for machine learning, this is more or less something which we're going to see more. It's the GPU enabled nodes. It's not the CPU intense. It's actually GPU, and those tensor processing units which Google introduced is probably something which you're going to see in the very near future. We can, if there are any questions, I can answer them now, because that's the end of this section. If not, I'll just explain those links.
No questions.
All right. So if you're new to this space and you want to learn something about machine learning, and you know very little, or maybe you come from the field which is not engineering field, I encourage you to look up this guy, Lex Fridman. He is a MIT research scientist. So he has lectures, like MIT lectures online. You can actually see some of them, very digestible. But he, most interesting, at least to me, he has a number of interviews. He has a YouTube channel. So if you go to this link, you will see all those videos in here and interviews. And he interviews interesting people. I think his channel is actually called Artificial Intelligence. But he interviews the people from interesting people from all around the world. Since I assume since he's associated with MIT, he has access to MIT people. Interesting, like Noam Chomsky, for example. He has interviewed, or a couple of interviews with Noam Chomsky. Really interesting. They go deep into other aspects of artificial intelligence, not necessarily like a technical aspects of it, but also like how humans are going to be affected and so on and so on. He has an interview with Elon Musk. So if you want to start just try to understand what machine learning means in the real life, I think you should actually look him up or follow this link and check few videos which may be interesting to you. If you're, on the other hand, if you are a programmer or someone who is willing to spend a little bit time playing with it, I think Python is probably the safest way. Python has a really nice library for TensorFlow library. And if you combine these two, most likely you will be able to play with this. PyTorch, it's another option for you. And if you want to even go farther, you can actually use the Google tutorial for it. So that would be my thinking if you want to just touch on that space. So if there are no questions, I'm going to move to the last section, which is cryptocurrency. And this is the section which I truly enjoy, the part of presentation. And my excuse to introduce you for this is because one of your requirements actually mentioned in-app currency. And in my mind, that's my excuse to introduce you to cryptocurrency. So the cryptocurrency started with one name, Satoshi Nakamoto. Satoshi Nakamoto, we don't know who that person is. Actually, it could be a man, it could be a woman, it could be a group of people, it could be an organization. The truth is, nobody knows it for sure. Although some people claim they are Satoshi Nakamoto, and some people basically say that's not me. But regardless of that, I'm going to refer to Satoshi Nakamoto as a person, he. But we don't know. He solved the double spending. So you think about the digital currency existed way before Satoshi actually introduced Bitcoin. What he introduced is he's saying, well, you know what? I think I solved the double spending, meaning I don't know if you remember, but there was a big battle about the MP3s. MP3s used to be shared kind of semi-legally on peer-to-peer network, and then you see now that became actually a business. So the problem with MP3s was when they arrived that if I have a copy of it, I can make another copy and another copy and another copy and another copy, and each copy is as good as the previous one, assuming we didn't change anything, right? So none of those copies losing value. That's not a desired function for digital currency. You want to know that if you have a $1 and you spend it, you can't spend it again and again and again and again, because eventually you'll just need $1, right? You don't need anything else. So when you spend it, you know that you cannot spend it again. If you gave it to someone, that someone will take ownership of it, and that someone will be able to spend it, but you won't be able to spend it again. So Satoshi Nakamoto said, well, you know what? I finally figured out how to solve this double spending, and he wrote a white paper. And if you're curious, read it, because this paper is actually in the readable format. You as a human being can read it. There's a couple of equations in there which you can skip if you don't want it, but it's a very readable format and it's short. And then he said, okay, I have this white paper. This is how I solve the double spending. And basically, of course, there's a number of people saying, well, that will never work, right? So instead of arguing with him, with them, he released Bitcoin. So he released the code in January 3rd. He created the first Bitcoin block, which we call Genesis block, and that block has a placeholder where you can put some memo in there. And he put a quote from the London Times, which basically in 2008, if you recall, there was a financial crisis, and then Chancellor on Brink of second bailout for banks, right? So he put that, and this is in the first Genesis block of Bitcoin. And if you want to look at this a little bit more in detail, just look at this link which I provided in here. But what is cryptocurrency? Well, it turned out that there's actually a definition for it, and I don't want to go through the whole definition, but what's important is there's no central authority. Then the system by itself maintains the units and their ownership, so there's no middleman. The system defines circumstances when the new cryptocurrencies units can be created. Basically, it says, well, are we going to mine it? Are we going to introduce it in some kind of cadence? Are we going to create it upfront and it's going to be quadrillion of whatever tokens or crypto? Or are we going to have a cadence where it's created and how it could be created? And then the ownership of this can be proven basically cryptographically. There's no bank who is saying, yeah, this money belongs to person A and this belongs to person B, and we're a custodian of it. There's nothing like that. The whole algorithm actually keeps track of everything, and the system ensures that whoever has the private key owns this crypto. So the ownership can be transferred to another person, and that another person will use their own private key to secure it. And so far, this proven to be very, very safe. There are billions of dollars. Bitcoin cap market, I think it's 150 or 160 billion dollars. So far, nobody broke to it. And the system prevents from double spending, which I mentioned. And there's a link if you want to just read a little bit more about the definition and who created this definition and if this definition is recognized, right? So the first cryptocurrency created by Satoshi Nakamoto was Bitcoin, and Bitcoin is a cryptocurrency based on that definition. Decentralized. So there's no middleman, there's no bank. You are actually becoming a bank for yourself. So each person who has a Bitcoin basically represents that bank. And apparently there is no single place where you can go and shut it down or enforce certain behavior. So that's basically the idea. And there's no middleman. And this is basically a landscape. And this is misleading because you probably, some of you may heard about about blockchain. Blockchain is just the one component of this Bitcoin landscape that, or Bitcoin created this landscape, but in general sense of cryptocurrency. So blockchain is just one of the components of this landscape. It's not like a blockchain means cryptocurrency. Because blockchain by itself is just distributed ledger, right? It's immutable, so it has very desirable properties, but it's not cryptocurrency or Bitcoin by itself, or cannot be, because you still need consensus algorithms, basically a validation of all those transactions, the network which will allow you to for those transactions to be available to all the nodes, and definitely based on cryptocurrency, which is owner protection. And this cryptocurrency came from the resources, which there's a lot of innovation happening in that space. Now that was Bitcoin. Now I'm going to introduce you to something slightly different, which is called Ethereum. And Ethereum, it's also cryptocurrency, but it has slightly different approach to it. So instead of thinking about the Bitcoin, like Bitcoin, it's more or less like an exchange of value between two parties. Ethereum is a platform, and it's a platform for decentralized cryptocurrency. So it also has this interesting parts in here. You can build smart contracts and applications on the top of it. The smart contract is that you have one party and you have a second party, and they have the contract which is written in this language, which is specific to Ethereum. And instead of having a middleman or escrow service, they agree to this contract, and then this network ensures that if the conditions are met, this contract is going to be in effect, and then maybe some kind of payment will actually go from one party to the other. So there's no need for a middleman in here. That's the smart contract, eliminating the middleman. And then The other interesting part is the ICO. ICO is like IPO in stock, initial coin offering, and it's been widely used to crowdfunding. Instead of looking for a venture capital to sponsor your ideas, you release the white paper, you release some code, you release the roadmap, and people are trying to buy you tokens. And as soon as they buy the tokens, you have the budget to develop the functionality. Two things are worth mentioning. There's multiple of those things, but since Ethereum is a platform, they also have Ethereum request for comment, and they basically have a number behind this. They have a concept of fungible tokens and non-fungible tokens. You can create your own cryptocurrency on the top of Ethereum. So they call them tokens. Those tokens, fungible tokens, it's like a $1 bill for $1 bill, and non-fungible tokens, it means that those units are not interchangeable. One person is not the same as another person. So you cannot just get your kids replaced by with some other kids. They're not the same, although you may actually like that, or maybe your parents would like that. But the idea is that each token in this case, it's unique in a sense, but you can still transfer it to another owner. So I have a bunch of links in here to follow up. If you want to learn what Bitcoin means, this is the Andreas Antonopoulos. He's probably the best person to go to. He's like Lex Friedman. He touches so many different aspects of cryptocurrency, not just technical. And if you want to learn something on daily basis, especially in you're techie, check this guy. He's funny, but he brings like some kind of a very short learning, like a 5-minute learning thing, and he brings like a news from the world in that space. So you can check those things. Now, I don't know if this is going to work. Let me see. Well, for some reason that doesn't work. Let me see if I can do some magic. All right, so that doesn't work. That's a pity because that was a funny. Maybe I need to get that. Nope. Sorry for this glitch. Nevertheless, there's an application written on the top of cryptocurrency. I'll send you a link. Actually, the link will exist in here. But the idea is that there's applications written on the top of Ethereum, and this Ethereum has the application called CryptoKitties, and CryptoKitties is the application which allows, which basically creates those unique assets, and they're called CryptoKitties. And if you look at this one is interesting. I just pulled it like from last week. This CryptoKitty in here could be yours for only $3,602.72. Actually, probably 73 cents because there is a shipping, 1 cent shipping. So if you think that this whole thing is just made up stories, just look at what people are willing to pay for digital assets. And if you think that this was actually absolutely crazy, pay like so much money for it, I have like a top 3, and just look at the how much this guy's actually fetched on the market. So $173,000 for this crypto kitty called Dragon, which I don't think is the prettiest one, but nevertheless, they're ideas. The ideas, each of them is unique. Each of them has a unique ID, basically tied up to the CryptoKitty token. And that means if you own it, you can sell it, you can trade it for another kitty. And then if you have 2 of them, and they're compatible, they can breed, and then basically they can produce maybe this guy who will fetch some kind of good price. They have certain properties, so those properties are really like a DNA code. When you match them, you can get some kind of interesting offspring out of them, and then you can start making money. So I brought this because this is slightly crazy in a sense, but it at least gives you some kind of idea that this cryptocurrency, it's probably not named properly, because it gives you the impression that this is just a money exchange, like, instead of dollars you use some cryptocurrency, but it's more like an intranet in the early stages. The intranet first application was email, right? But it wasn't internet wasn't built for just email. Internet was built as an infrastructure for for the web, right? And the web allow you to create multiple applications on the top of it. And the same thing, it's about the cryptocurrency. The cryptocurrency, it's a platform where you can build your applications on. One of the first ones, like in the internet days, was email. Now you see that there's first ones are related to the physical assets, maybe tokens, maybe like a Bitcoin and so on. But this is not limiting uh, the functionality of it. So think about it from your perspective, from your delivery, how this cryptocurrency could change this whole approach to learning. If you think about the learning in the way that you'll become a global, how can you make sure that the poor students will be able to learn in your platform, or be able to afford this the same way as the rich ones? Maybe you need to introduce your own token in there, which will maybe be the game equalizer, which will allow to these guys, to the poor guy, to earn some of those tokens because this guy is smart, not because he has money to learn, right? And then maybe you can actually monetize your application, saying, you know what, we're going to ask whoever is going to sell anything in here to sell them for those tokens. So those people who earn tokens maybe can have access to those providers who have a paid content. And there's so many options around that. That's why I put some links in here, just to get you interested in the space, because this space is really promising. It's as promising as the machine learning space. And this is my last slide. So I know that we're like a 1 minute over or something like that. Uh, I just brought this because it's kind of funny in the sense, because this is from CryptoKitty's site. Someone asked why cats, right? I like this one. Cats. Cats don't discriminate. They despise everyone equally. I thought it was funny. Anyways, I think this is all. If there are any questions, I can answer them. I can still state. If not, I think we're done.
There's one question and one comment. So the question is from Eddie. So he's asking, do you own any ETH right now? Just curious.
So Ethereum is a very interesting currency. I actually own a tiny bit of many of them, and for reason not for an investment perspective. I'm curious about technologies. So for me, it's more interesting to actually look at those tokens, especially what they have to offer. So I would encourage you to do the same. Don't think about getting rich in crypto. Most likely you're going to lose your money extremely fast, especially if you don't know how to protect it. But owning a tiny piece of them, and I think they have like 8 decimal places, so you don't have to spend a fortune on it, will allow you to play with it, how to exchange, how to protect it, how to move it from one type of storage to another, how to give it to someone, and so on. That will give you some kind of idea of how to use that first internet application email. You'll be one of the first people who knows how to do it. That would be my approach to it. Don't look at getting rich in there, because if you don't know how to protect it, don't even buy one. I mean, don't buy anything which is valuable in a sense. Don't spend like thousands of dollars. I would say before you put money in there as an investment, learn how to protect it. Unless you know that part, don't buy anything what you think you can't afford to lose, because most likely you're going to lose it.
And there's a comment from El Has. Sorry if I put your name. He was making a comment about the kitty, and he said it's both cool and insane at the same time.
Absolutely. I agree with that statement. When I actually ran into this CryptoKitties, I thought, who would ever pay that type of money to the digital asset? But when you think about what we humans were doing in the past, there's many items which we thought they are special. Why they are special? Because they're unique. If there's scarcity of anything, the price goes up. And that same was about the baseball cards, stamps, whatever was unique fetched more a higher price, and there is always people who want to have that unique item. And I think that cryptocurrency, and it's not named properly in my opinion, but that the cryptocurrency technology allows us to start digitizing anything which is true. Like, even if you think from the perspective of the stock, when you buy a stock, when I buy a stock at Fidelity buys it for me. Then it takes 3 days to clear it for clearance bank, and then it comes to my account, and Fidelity tells, okay, now you have one Microsoft stock, be happy. But this stock, it's not mine. It's Fidelity's stock, which Fidelity has on the books, which has a pointer to my account, right? I don't know how many times, if anyone else owns the same stock. And Bernie Madoff, right? He had the Ponzi scheme. Uh, so there could be so many Ponzi scheme. This cryptocurrency technology allows us to actually tokenize anything and guarantee that there's only one instance and who that instance belongs to. And I think that would be the future of tokenizing the whole world. That your house will be tokenized, and you can actually sell it by giving that token to someone else, and someone else will own it moving forward. There is no middleman required for that anymore. The overhead of a middleman is extreme. If you look at the details of it, you will be surprised how many resources we lose every single year on middlemen.
Great. Any other questions? I don't think there's any other questions. So thank you, Lucas. It was indeed an exciting presentation. Our students must have enjoyed the presentation and got insight into the information architecture. And thank you so much again. Good night, everyone.
Good night.